Hi, Expo Algebra. This is Mr. Monahan. We are looking at the Chapter 11 practice test today on this video. So this is going to be very, very similar to what you will see on the real test. So take some time to look at ones that you were not sure about. Feel free to fast forward or rewind or whatever you need to do to have make sure everything here is making sense. So I'm just going to go problem by problem. If you don't need to look at the first chunk, feel free to skip ahead to ones that you did have questions on. All right, so numbers 1 through 4 have two things in the directions. You're going to simplify and you're going to do excluded values. You're going to do both of those things. So when we look at excluded values, what we are talking about are things that make the denominator equal 0. So what we do is we talk about those excluded values. We set the denominator equal to 0. And we want to do this before we reduce or cancel anything. What we're looking for is just what number are we not allowed to put in, because it gives us a 0 in the denominator, which we're not allowed to have. So we know from this work, 0 divided by 30 is just 0. We know that x is not allowed to be 0. So x cannot be 0. That's the excluded value. Then the rest of the work is just that simplifying. So I'm going to reduce this one. The 20 and the 30, that reduces all the way down to 2 over 3. And then I can subtract exponents here. So I have 2/3 so far. I can subtract exponents. I have 3 x's up top and 1 in the bottom. This x on the bottom will cancel one of these x's in the top. So I still have an x squared. So my simplified answer is 2x squared up top, 3 on the bottom, and x is not allowed to be 0. Okay, moving forward here, you want to factor these by taking out a common factor of each. So 2 on the top and 5 on the bottom. You're going to notice that there's going to be some w minus 6's that will cancel, that are supposed to cancel. Before you do that, do the excluded value step. I'm not going to use anything with the 5, but the w minus 6, if I put something in there, I could get a 0 if I add 6 to both sides. W being 6 would be a problem for me. If I put 6 in the bottom, then I get a 0 out, and I don't want that to happen. That's not allowed to happen. So W cannot be 6, and my final answer is now I'm going to cross out my W minus 6's after I've done my excluded value step, and the reduced version of this, this expression is 2 over 5. Okay? Again, we factor first, then we do excluded values, then we cancel, cross things off. So, up top, we have what's called a difference of squares. That's this stuff right here. X squared minus 4. This is called a difference of squares. And what that is a time when we have something in the form of a squared minus b squared. What we're able to do is factor that by taking the square root of a and the square root of b. So x squared minus 4 would factor into x plus 2 times x minus 2. The bottom, two numbers that multiply to 10 that add to 7, would be positive 2 and positive 5. 2 times 5 is 10, 2 plus 5 is 7. Again, I'm going to cross off the x plus 2's, but before I do that, I need to set x plus 2 equal to 0, and x plus 5 equal to 0. So there's two ways the bottom could be 0. One is if I plugged in a negative 2, so x not allowed to be negative 2. One is if I plugged in a negative 5. So those are my two excluded values in either order. Okay, after I've done that, then I can cross off x plus 2's, and I'm left with my answer, x minus 2 on the top, x plus 5 on the bottom. The last one like this, same idea, a little bit tougher factoring on the bottom. There's no factoring to be done up top. On the bottom, we're looking to try to factor 2x squared plus 7x plus 3. For 2x squared, I have to use 2x times x, so I'm going to put those in the front spots. Everything is positive, so I have a plus and a plus. I want to try to make a 7 in the middle. My only way to get to 3 is 1 times 3. So I'm going to try to put the 1 here and the 3 here. If I FOIL that out, you'll see that the 2x and 3 make 6x, and then the insides of 1x, 6 and 1 will make 7x in the middle. I'm going to be able to cross out the x plus 3's, but not until after I find my excluded values, and there's 2 of them. One of them is when I subtract 1 and then divide by 2. So negative 1/2 would be one of them. One of them is when I subtract 3 from both sides over here. I'm just going to rewrite it so you can read it. X is not able to be negative 3 either. So the excluded values are negative 1/2 and negative 3. Now I'm going to go finish this problem. The x plus 3's are going to be able to cancel. Up top, all that's left is a 1, so I'm able to write 1 over 2x plus 1 for my final answer for that one. So this one has a final answer of 1 over 2x plus 1. To be safe, you can put the denominator in parentheses. So that's how you simplify and find excluded values. Now let's talk about multiplying and dividing. Multiply, you can reduce first or you can reduce last. So some people like to multiply first and then reduce. Some people like to reduce first. So what that would mean is something like this, like 5 would go into 15 3 times, so I could replace that with a 1 and a 3. 3 would go into 9 3 times, and then I have x's. So the x squared up here is going to cancel 2 of the x squareds down here. So there was 4, now there's only 2 left. So up top, all we have is 1 times 3. On the bottom, all we have is 3 times x squared. And I could have done one more step in the last step, but I just wanted to show you here. These 3's can also reduce. 3 goes into 3 once. So the best answer for this one is going to be 1 over x squared. So there's a lot of different ways you could do number 5 as long as you get down to that same answer. On mine, I just have a small mistake. Here we go. So this is supposed to be one of the dividing problems, so I'm just going to put that in there so that's easier to see. So for 6, this is a dividing problem, which means we need to flip the second fraction. It's called taking the reciprocal. So we're going to flip that second fraction, and now we're going to treat it just like a multiplying problem. We're going to reduce as much as we can, and then multiply straight across. So I see over here, I see that 2 can go into 4 twice. I see these a's that can just cancel. And then I have, that's it. That's the only thing that can cancel up top with the bottom. So on the top, I have an a squared still. I have 2 b's, so that's going to be b squared when they multiply. And then on the bottom, I have 5 times 2, which is 10. So that would be our answer to number 6. Okay, number 7 is a multiply problem. First thing we want to do is factor everything that we can. So take a 5 out of the top left and take a 4 out of the bottom right. Okay, then we're not doing excluded values. We can go to canceling. X plus 2's can eliminate. I have this 8 or this 4. It doesn't matter which 4, just picking one. This 4 goes into this 8 twice. This 2 over 4 is just 1 over 2. And then this x here can cancel out one of the x's here. So all that's left on top is a 5 and an x. So 5x. All that's left on the bottom is a 2. So 5x over 2. Okay, number 8, very similar steps. We're going to do a GCF of the top left. We're going to take a 7 out. Nothing can be done with the lower left. We can take a 3 out of the upper right. We can take a 2 out of the lower right. Okay, so we're going to get quite a bit to cancel this time for number 8. All the variables, things with variables will cancel. 2x minus 3's and x plus 1's. This entire denominator is gone. I'm going to replace it with a 1. And then none of the numbers can simplify here at all. but we can do 7 times 3 up top, which is 22, and then we have 1 times 2 on the bottom, which is 2. Okay, moving on, number 9 is a dividing problem. It's just kind of printed funny for me, so I just want to make sure that I don't mess that up. So we need to reverse the second fraction, which is called taking the reciprocal. So when we try to divide fractions, we're really interested in multiplying by the reciprocal. We take that second fraction and we flip that. Okay, then we look to factor as much as we can. We're going to take a 2n out of the upper left, and we're left with 2n minus n. Oh, I can take a 2n squared out. Sorry, that's going to be a little bit better. 2n squared, and then that's going to leave me with 2n minus 1. There we go. That's better. N squared minus 9, that's another difference of squares, n plus 3 and n minus 3. And then we have an n plus 3 in the numerator already in the upper right, and we have an n squared on the bottom. Okay, we're going to try to simplify what we can here. We're going to eliminate n plus 3's. We're going to eliminate this n squared with this n squared. That's just a 1 now, and that's all we can do. So for this one, we're at our final answer. We have a 2, we have a 2n minus 1 left up top. We have an n minus 3 on the bottom. And that would be it. So that would be our final answer for number 9. And number 10 is also dividing. So it's going to be very similar to begin with. First thing we want to do is flip the second fraction. Leave the first fraction alone for now. That second fraction has a difference of squares in it again, so my next step I want to take is to factor everything. And you see also an 8 and a 16 that we'll be able to reduce here very soon. The upper left is going to factor, and it's going to factor like this, 2x plus 1 and x plus 6. Okay? That's going to be the only way to get 13x in the middle while having a 2x squared out front. The difference of squares factors like this, x plus 6, x minus 6, not 36. Okay, so that's that one. Now we're going to reduce what we can. X plus 6's can go. 8 goes into 16 twice, and that should be the majority of what we're able to do. So we're left with a 2 and a 2x plus 1 on the top. We're left with just an x minus 6 on the bottom. And that would be our final answer. So 2 times 2x plus 1 over x minus 6. Okay, that's page 1 of the practice test. Let's go on to page 2 when we talk about adding and subtracting. The trick with adding and subtracting is to make sure you have the same denominator. If you do, you're able to add across the top right away. With adding and subtracting, once the denominators are the same, you don't combine them, you just copy it into the next step. So the denominators don't change for these if you already have them as common denominators. Up top, be very careful that you don't call that 16x. 4x and 12 cannot add to be 16x because they're not like terms. So that's all I can do here, but I can reduce this by taking a 4 out. And then now this 4 and 2 can become 2 over 1. So I would have 2, I would have x plus 3, and I would have just an x on the bottom. And that would be my final answer for number 11. Number 12 is another one that already has the denominators as like denominators. So that's more good news. So sorry, this was 2x plus 3 over x. This one, number 12, same thing. The denominators are already common. So I can add the 2x plus 6 up top. They don't combine, but I can add them together. I have x squared plus 7x plus 12 on the bottom. But then I want to try to factor everything. So I want to go take a 2 out of the top. I'm going to show my work down here. I'm going to take a 2 out of the top, and then I have x plus 3 here. And then the two numbers that multiply to 12 but add to 7, that would be 3 and 4. So since x plus 3's are the same right here, I can eliminate those, and I'm left with 2 on the top and x plus 4 on the bottom. And that's my answer for number 12. Okay, if the denominators are the same, you can go right into adding those. So let's do that then. So number 13, we see denominators that are already the same. So one thing to be careful with here is you need to understand that this is a minus sign. And when you subtract an entire group of things, you want to be very, very careful with that. Okay? Because both the 2y and the 2 are being subtracted. So one way that we've looked at this before is we've added opposites. So we've changed the subtraction into addition, and then we've taken the opposite of 2y and the opposite of 2, and that has seemed to help people remember what is really going on here. So 5y and 2y would be called like terms. We would subtract those and we would get 3y, and then we have a negative 2. On the bottom, we still have our same denominator, but then we look to factor. There's nothing I can take out of 3 and 2, so the top is staying the same, but the bottom has a factor of 3y minus 2. You can do 3y minus 2 and y minus 5, and you can FOIL that out if you don't see why that works. But what we have now is we have 3y minus 2's that are going to be able to cancel. So I can get rid of the 3y minus 2's. The entire numerator is gone, so I'm going to replace it with a 1. And we see our final answer of 1 over y minus 5. When we start to have different denominators, that's when we have to think about our steps again. We have to find a lowest common denominator when this happens. Okay, so for number 14, our lowest common denominator, first we look at the 5 and the 2, and we look for the smallest multiple that they both have, which is 10. And then x to the third and x squared. Since the one on the left already has an x to the third, we take that higher exponent. So the lowest common denominator has to do with finding something that makes both fractions equal 10x to the third. So the fraction on the left is 5x to the third. If I multiply the 5 by 2, I get 10. Whatever I do to the top, I need to do to the bottom. So I get 4 over 10x cubed plus this one on the right needs to get multiplied by 5, but it also needs another x. So this one has to get multiplied by 5x over 5x. So that's a distributive situation. 5x times 4 is 20x. 5x times x is 5x squared. All of this is over 10x squared. Our whole mission here was to get the denominators to be the same. Now that they are, we can add across the top. I don't see any like terms at all here. We have a 5x squared, a 20x, and a 4. I just put them in standard form, so I rearranged those. And then we could look to try to factor the top, but there's not going to be a way to multiply to 5x squared out front, multiply to 4 at the end, and have whatever multiplies to 4 at 20. There's no GCF of the top, so there's nothing I can take out of this at all. This is my answer for 14. A lot of times, not always, but a lot of times when you have to find a common denominator, there is not a lot of simplifying at the end. If for some reason you don't have the smallest denominator, that would lead to some more situations where you might have to simplify. Okay, 15, lowest common denominator. Okay, when there's a plus sign in one of them, so we have a binomial here, we just take the two denominators and we put them next to each other. So that would be x times x plus 1. So what we do is each fraction has to get multiplied by what it doesn't yet have. So the one on the left needs to get multiplied by x plus 1s, The one on the right needs to get multiplied by x over x. So we're going to rewrite the first fraction, 3x over x times x plus 1. Notice how I'm not distributing the denominator. I'm just leaving those in factored form. The right-hand fraction, distribute the 2 in. We have a 2x and a positive 2. We have to be careful with our negative there, so we'll look at that again in just a second. Okay, the bottom is x times x plus 1 again. If it helps you to think about adding opposites, that might be a good idea. So take the opposite of both of the signs inside. So it's a negative 2x and a negative 2. Then I'm ready to start simplifying. 3x minus 2x is x, and then I have a negative 2. On the bottom, I have x times x plus 1. Okay, that's my final answer. If it helps you to put the x minus 2 in parentheses to help you remember, there's nothing that I can cancel with the x minus 2 and like the x or the x plus 1 on the bottom, because x minus 2 is not the exact same thing as anything in the denominator. Okay, number 16, the lowest common denominator is just going to be 3x. Okay, the fraction on the right is already over 3x, so I don't need to change anything in the right. The one on the left needs to get multiplied by 3 over 3, so I need to distribute a 3 in. So what we have here is 3 times 5, 15, and 3 times x, 3x. Okay, so now I have a situation where I'm able to add opposites again. I'm going to change this to a plus, and I'm going to change the 2 to negative 2 and the negative 7 to positive 7. Now I'm combining like terms. Let's do the x's first. I have 3x minus 2x, which is 1x. I have 15 plus 7, which is 22. On the bottom, I have 3x. Can't take anything out of the top, which means that's my answer. X plus 22 up top, 3x on the bottom. A couple more just like this. Number 17 is like 15. So the lowest common denominator is putting those two denominators together. So the lowest common denominator for this one is x plus 1, x minus 1. So let's do that. This one on the left needs to get multiplied by x minus 1s. This one on the right needs to get multiplied by x plus 1s. So we have 2 times x minus 1, distributive property, that's 2x minus 2 over x plus 1, x minus 1. The order of your denominators isn't going to matter. Here I have 3 times x and 3 plus 1, so 3x plus 3. And then now we have the same denominators for both. Okay, we're adding opposites. So let's change this to plus, minus 3x and minus 3. 2x minus 3x is negative x. Negative 2 plus negative 3 is negative 5. On the bottom, we have x plus 1, x minus 1. And that could be your answer right there. If you factored out a negative, that would be okay too. So you could have a GCF of negative 1. If you chose to do that, then that's perfectly fine. Nothing wrong with doing that. And then the last one has the same GCF as 16. Lowest common denominator is going to be 3x for number 18. The one on the right needs to get changed. The one on the left is already over 3x. So the one on the right needs to get multiplied by 3 over 3. So this is going to be rewritten as 6 over 3x. Okay, well then all I have to do is add the 1 plus 6. I have 7 over 3x. Nothing can reduce because 7 and 3 don't have any common factors. So that's the add and subtract page. Okay, the last page is going to have our other ways of dividing. So the first one, number 19, is dividing by a monomial. And when you do that, you're just writing each piece of the polynomial as a separate fraction. We're dividing each of these by just a 2x. So when you divide the coefficients by 2, we know how to do that. When we divide all the exponents by x, we're just going to reduce every exponent by 1. So 4 divided by 2 is 2, and I'm taking one of the 4x's away. Negative 6 divided by 2 is 3, and I'm taking one of the 3x's away. 18 divided by 2 is 9, and I'm taking one of the 2x's away. And that's it. No like terms to combine at the end. Okay, we're down to our last two here. X squared minus 7x plus 10 divided by x minus 1. This is long division because we have a binomial that we're dividing by. I think on the real test, the directions tell you when to do long division, just like this does. But what we're going to do is we're going to put x minus 1 outside. We're going to put x squared minus 7x plus 10 inside. Okay? What we're trying to do is cancel out the things that are furthest to the left. So I want to get rid of this x squared using this x right here. So the thing that I need to multiply x by to get x squared is x. So that's what goes up top, because x times x is x squared. Also, x times negative 1 is negative 1x. So that's the other step we need to take. Then we're at the point of long division where we subtract. Before you do that, you want to put it in parentheses. Okay, and again, just like we've been doing a lot, you can look at it as adding opposites. So we can add a negative x squared and add a positive 1x. Okay, the x squared and the x squared should cancel out. X squared minus x squared is 0. We have negative 7x plus 1x, which is negative 6x. After that, we bring down the next term, which was a positive 10. Okay, now we're back to what we were doing before. We want to cancel out negative 6x using the x out front. So the thing I'm going to put up top this time is whatever I need to multiply the x by to get negative 6x. Well, that would be a negative 6. Negative 6 times x is negative 6x. Negative 6 times negative 1 is, careful, positive 6. We're going to put this in parentheses, and we're going to subtract. You can think about it as adding the opposites if you want. So this is adding a positive 6x and adding a negative 6. Okay, 10 minus 6 is what we're doing there. The 6x cancels out the negative 6x. We have 10 plus negative 6, which is 4. There's nothing left to bring down, so this becomes our remainder. So since it's a positive 4, we write plus, and then we have 4 over whatever we were dividing by. This time it was x minus 1. So our answer is x minus 6 plus 4 over x minus 1. Okay, let's try that one more time. What could happen to you is they skip over something. So this one goes x squared and then right to 28. So it doesn't include anything with an x to the 1 term. So we have x minus 5 on the outside. In here we have x squared. We have a negative 28. But what I'm going to include is a plus 0x. And that's going to help me line things up a little bit better in just a moment. So let's play our game. X squared needs to get canceled out. I need to multiply x by something to get that. And that, again, is just x to the 1. Because x times x is x squared. X times negative 5 is negative 5x. Okay, put that in parentheses and subtract. Okay, add the opposites. The x squareds are going to cancel. That's what we wanted. 0x plus 5x is 5x. Bring down the next term, negative 28. Then we're looking to cancel out 5x with x. So we need to multiply the x by something to get 5x. That's going to be a 5, and I want it to be a positive 5 since I have a positive 5x underneath. So positive 5 times x is 5x. Positive 5 times negative 5 is negative 25. Okay, be careful here, but parentheses, subtract, add the opposites. 5x's are gone. Negative 28 plus 25 is negative 3, and that's our remainder. Negative 3 over x minus 5. So our answer for this one is x plus 5 minus 3 over x minus 5. And that's it for the practice test. Everything you saw on there is important for what you'll be seeing very, very soon on the real test. Let your teacher know what questions you have and have a wonderful day.